This is section 6.2, confidence intervals for the mean when we're using small samples. So we're going to interpret the t-distribution and use the t-distribution table, construct a confidence interval when n is less than 30, population is normally distributed, and sigma is unknown. So the t-distribution, when the population standard deviation is unknown, the sample size is less than 30, and the random variable x is approximately normally distributed. It follows a t-distribution. The critical values of t are denoted by TC. Now you can use a table or Excel to find TC. The t-distribution is bell-shaped and symmetric about the mean. The t-distribution is also a family of curves, each determined by a parameter called the degrees of freedom. Degrees of freedom is just n minus 1, or 1 less than the sample size that you are given. The total area under a t-curve is 1, or 100%. The mean, median, and mode of the t-distributions are equal to 0. As the degrees of freedom increase, the t-distribution approaches the normal distribution. After 30 degrees of freedom, the t-distribution is very close to the standard normal z distribution. So as you get a degrees of freedom 2, the curve is really not as tall, and it's really far from the axis. But as you increase your degrees of freedom, it's going to get taller and closer to the x-axis and appear to be turning into the normal distribution. So the tails in the t-distribution are kind of thicker and further away from the axis than those in the standard normal distribution. So find the critical value, TC, for 95% confidence when the sample size is 15. So first you can use a table. You can find degrees of freedom by taking n minus 1, which is 15 minus 1, or 14. So go down the left-hand side and find 14 degrees of freedom, and then go across the top and find 0.95, which is our confidence, and we're going to get 2.145. Now if you want to use Excel, I have the function right there for you. You would type in equals t.inv.2t, because it's a two-tailed test, which is all we've kind of seen so far, which just means it has both of those spots on the right and the left side of the curve. So the 95% happens in the middle. And then we're going to put 1 minus c, or alpha, 0.05, divided by 2, comma, degrees of freedom, 14. It's just alpha and then degrees of freedom 14. So we get 2.145. So the slide right here does not need to have a divided by 2. So the solution was we got a t-score of 2.145 for 95% confidence. Confidence intervals for the population mean. You would still do the same thing we did in the previous section, where we add and subtract the mean. We take the error and subtract it from the mean, and the error and add it from the mean to the left and the right to get our confidence interval. It's just now the formula's changed a little bit. We're no longer using a z-score, we're using a t, so we're going to have to replace t with the tc, and we're timesing it by s divided by the square root of n. The probability that the confidence interval contains mu is c. So in words, first we need to identify the sample statistics, n, x bar, and s. Now as I covered previously, you can use average to find the mean, and you can use stdev.s in Excel to find the standard deviation. Then we need to identify the degrees of freedom, the level of confidence, and the TC, the critical value. So first, the degrees of freedom is n minus 1, and then the level of confidence would be point whatever it is, and then the critical value would be using Excel, t.inv.2t, and then plugging in alpha, comma, degrees of freedom. Then we need to find the margin of error, which is error equals that the t we just found in the previous section, and then s divided by square root of n. Then we need to subtract and add e to the mean to get our interval, just as we did previously. So, example, constructing a confidence interval. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 degrees Fahrenheit. With a sample standard deviation of 10 degrees, find the 95% confidence interval for the mean temperature, assuming the temperatures are approximately normally distributed. So we're going to have to use a t-distribution because it's less than 30 and sigma is unknown. So we have n equals 16, x bar equals 162, S equals 10, and C, our confidence interval, is 0.95. So degrees of freedom would be 16 minus 1, or 15. And then we could plug this into the table, and we find that 2.131 is our t-distribution. Now you can also plug this into Excel. There's a lot of ways to plug it into Excel. The t.inv.2t works with alpha, comma, degrees of freedom. And then this Excel right here, t.inv 1 minus c divided by 2, gives you the negative, and then if you want a 1 minus alpha divided by 2 for the positive. So then the margin of error, we plug this in, what we just found, 2.131 times 10 divided by the square root of 16 equals 5.3. Now we take that and subtract it from the mean and add it to the mean that they gave us in the problem. So left end point is going to be subtracting 162 minus 5.3. And then on the right we're going to add it. 162 plus 5.3. That gives us our interval of 156.7 less than mu less than 167.3. So we know with 95% confidence you can say that the mean temperature of coffee sold is between 156.7 and 167.3 degrees of freedom. So we have a normal, and we've learned the t-distribution. Now, when can you choose what? So first you need to ask yourself, is n greater than or equal to 30? If you answer yes, then you use the normal. If you answer no, you have to ask yourself a couple other questions. Is it normally distributed? If you say no, we can't do anything. It has to be normally distributed to do the normal and the t-score. Then you need to ask yourself, so if you say yes, then you need to ask yourself, is sigma known? If we know sigma, then we can go back and use the normal distribution. If we do not, then we go to our t-distribution. So you randomly select 25 newly constructed houses. The sample mean construction cost is $181,000, and the population standard deviation is 28. Assuming construction costs are normally distributed, should you use the normal distribution, the t-distribution, or neither to construct 95% confidence interval for the population mean? Well, it's less than 25. It's normally distributed, but they gave us population standard deviation, which means sigma. So in this fact, we're going to go back to the normal distribution because we know sigma, even though it's less than 25. So our parameter this time was mu, our distribution was t, and our critical values can be found by t.inv.2t alpha divided by alpha, comma, the degrees of freedom. In this section, we interpreted the t-distribution and used the t-distribution table and Excel. We constructed confidence intervals when n was less than 30, the population mean is normally distributed, and sigma was unknown.